Welcome back to day 3 of non-right triangles. We've dealt with law of sines, so solving missing sides, missing angles. For those problems that law of sines couldn't do, we dealt with law of cosines. Remember, those were mainly for the side angle side and side problems. And then today we're going to wrap up. So basically you know how to find any missing piece of any triangle. And we're going to use those pieces today to be able to find the area of any triangle. And so we're going to use the area of triangles using a sine equation. This again is going to work for all types of triangles. So let's draw again. Let's draw triangle ABC. We're going to label the opposite sides little a, little b, little c. And then let's get straight to the area formula. Area is going to be equal to 1/2 BC sine big A. I'll give you a second to write that down. Now let's break this apart. BC basically looks almost like our base and height. If you remember the area formula of a triangle before this formula, it was 1/2 of base times height. And B and C almost are base and height. Our adjustment there is that sine A factor. That's for when it's a non-right triangle. It always has to be the included angle, which means the angle between the two sides. So between B and C is angle A, so that's why I have to use sine A. If you want to know further why this formula is really true, I can explain it a little bit more in detail during class. But the nice thing about this formula is it's going to work for any of the sides. So I could manipulate, instead of using BC, I could switch over and say, hey, if we only had sides AC, well, the included angle between A and C is angle B. So my formula would be 1/2 AC sine B. Same thing works for the last side. If I only have sides B and A, I can use those, and I just need to use angle C because it's the included. So 1/2 AB sine C would be the third equation. Remember, that's again the same equation, I'm just manipulating it around. Now, we might have to use law of sines or law of cosines to find the correct information, but that's not that big a deal. Sometimes they're nice and they just give it to us right off the start, or sometimes we can just measure the correct things when we're looking for it. Alright, first example. We're going to find the area of the triangle, and I have triangle ABC. Side AC is 6. Let's label them little a, little b, little c. So little a is 4.7, little b is 6. We don't know little c. We know big C is 110 degrees. I'm seeing there, I know two sides and their angle that's in between them. So I know the two sides and the included angle. So that's ready to go straight into the area formula. And it's going to be 1/2 AB, because that's the two sides we know, and the included angle will be C. So my equation is going to be area equals 1/2 AB sine big C. Plug everything straight in. So 1/2 times 4.7 times 6 times sine 110. We can plug that straight into a calculator, and it's going to give me 13.2. We are dealing with area. The problem doesn't state any type of units. A good habit when there's no units stated is to actually write units squared, because area is always in square units. We found the length and the width. Alright, so that was a problem that they gave us everything. Plug it straight into a formula, you got it. Alright, next type, triangle ABC. We're going to find the area again. Big B is 80, big C is 30, AB is 3.046, and AC is 6. I'm going to go ahead and label my triangle, little a, little b, little c. So I know little b, I know little c. I don't know the included angle, but I know the other two, so I could use my angle sum theorem and say, well, all triangles add up to 180 degrees. And so I'm going to take 180, subtract 80, subtract 30, and that gives me 70. So that means that last angle had to be 70 degrees. Now that I know two sides and the included angle, I can go right into our sine area formula. So it's going to be 1/2. We know B and C, so it's area equals 1/2 BC sine A. Plug our number straight in. It's going to be 1/2 6 times 3.047 times sine 70. And that gives me 8.6 units squared. Now, these triangles, this is just one type. There could be a couple more of these where maybe we have to use law of sines or law of cosines to find a missing side. This is just an easier one that we could just subtract it from 180. But sometimes you might have to do a law of sines or a law of cosines problem to get the correct information to get started with this. All right, let's go to an application. All right, so here's an aerial shot of some farmland out close to where I live. And basically, let's say we've got a farmer that was wanting to put fertilize on his field, or he didn't know how big his field was, and he just wanted to figure out how much land he had. And we were going to help him out here. And so basically, I've got a scenario shot of it. And using some GPS, we can get some points, and we can sort of outline this. And the piece of land that I'm looking at is the one that looks like a triangle, or it's pretty similar to a triangle along the edge of the road. And I'm going to label it triangle ABC. Alright, now to get this here, we need to actually take some measurements, and using some GPS coordinates, what I've measured is side AC is 791.7, angle C is 76.9, and BC is 664.2 feet. Now, if you didn't have the luxury of aerials on this, you might have to measure all three sides and go from a side-side-side problem to find an angle, then to set into an area formula. It just depends on what all tools you have at your hand on which things you find first. And I was trying to find a side angle side here. Alright, trying to work this out. So we're going to plug it straight into our area formula. Area equals 1/2 times 664.2 times 791.7 sine 76.9. Plug that straight into my calculator. I get 256081.2. My units here are going to be feet squared because we were feet by feet. Most of the stuff, if the farmer wants to know how much land he has, he don't want to know how many feet squared he has. So let's go ahead and convert this to acreage. And a conversion unit, we know 1 acre is going to be equal to 43,560 square feet. And we could either just set this up a division problem if you want to, but lots of people like the factor label problem, so we'll set it up that way. 256081.2 feet squared, setting up my factor label. I'm going to put a feet squared on the bottom so it will cancel out my units and convert. I'll put an acre on top and put my correct conversion in between. So 1 acre was 43,560 feet squared. This will cancel out the feet squared unit, and I multiply the top. 256081.2 times 1 is 256081.2. Then I'm needed to divide that by the 43,560. And when I do that, I get about 5.88 acres. So we can see that this farmer has about 5.88 acres of land in that field. So he could use that then if he was trying to sell it. He could use it if he was trying to put fertilizer on, how many poundage per acre he needed, so he'd know how much fertilizer to order. He'd know how much crop to order to plant that field. So this is just one application of someone using area formula or having to use law of sines, law of cosines could have been applicable for this. Alright guys, lesson's done for the day. Hopefully we know how to do area of any type of triangle now.